Okay, guys, so now that we understood how we can run these things in Sandbox, which is all the process, all the information is done by us, let's try to do it by ourselves. Let's try to run it that normally, so that you can find your own information about the malware, not rely on Sandbox, because probably you want to know more in detail. Okay, so we have here our Sandbox, sorry, our virtual machine. In this virtual machine, we have an exercise under malware. You will have all the instructions in our labs. And we have here SUS. This is exactly the same guide that we saw before in the previous class. It is the same MD5, as you can see here, 527F, blah, blah, blah. So you can confirm it. But we are going to run it in our lab, okay? So what we're going to do here is we prepare our host with Process Explorer. So Process Explorer is ready to go, waiting for something that is going to run, giving us more information. So we set it up, it is running. Then we also want to set it up Wireshark. With Wireshark, we're going to come here, we're going to go to capture interfaces, and then we're going to select the interface where we want to sniff network traffic. In this case, it's just one interface, so it is not like useful. We click on start, and right away Wireshark is going to start listening for traffic. Okay, we're going to tell to focus on HTTP, because we know that this malware is going to connect to HTTP based on the sandbox analysis. We can just put the filter here, click apply, and this is going to just watch for HTTP traffic. Then finally, we're going to run our process monitor, which is also another tool that we describe. You can access it with procmon. If you want to access it directly, like I'm doing it right now, with just by doing a window run and put the name, you need to make sure that you have the folder of Sysinternals in your environment path variable. That's in control panel. You can go there, go to the environment variables, and actually I can show you here. If you click on Windows logo and then the pause or break, it's going to tell you right away to this system information. Here you can go to advanced system settings, and here to environment variables, and here you can go to the path environment variable, and you can see that we added here our sysinternals path. Okay, so you can do the same, and after you do that, you're going to be able to run quickly those different tools with those shortcuts that we just show you, like procmon. Okay, so now we run procmon, and as I explained before, we need to add a filter here, guys. Otherwise, we're going to start trying to match every single process, which is really noisy and is not useful. So we're going to say here, okay, so the process name is going to be sus.exe, because we know that that's our process name. We add it and we click on apply, and you can see that if we run process monitor, it's not showing anything because we have not run that specific process. So now we are ready to go. We have process monitor, we have process explorer that is going to tell us information about the process itself. We have Wireshark ready to capture any traffic, and then we are just going to run it. If you can see here the malware, it is presented with this icon as Excel file, but we all know that it's not an Excel file. If we do a dir in that specific folder, we can see that that is an exe, right? But in Explorer, there are some tricks that the malware use in order to present it as a specific file. In this case, you cannot see the executable. Okay, so before running the malware, I'm going to show you in LordPE how it looks from the static side. It is always recommended, as I tell you before. So we go to malware, we open it here, we have the PE header as we learned in previous courses. If we go to the different directories, I want to show you here the export table is 0 as expected because it's not a DLL. In the import table, we can see that it has all those different APIs helpful for us. We can right away see, for example, as I mentioned before, these different APIs, like specifically WinINet, and these are the exports, which is telling us, okay, here is the internet read file. Okay, it is giving us clue that this is probably is going to connect to internet. So that's the usefulness of going to the import table. I mean, you can feel free to go and check. After that, another static check that I'm going to show you is strings. It is always recommended, guys, that you run strings, which is basically going to print all the strings, human readable strings inside that binary. That can give us clue about it. So strings is also part of our Sysinternal tools, so we can just put strings command, run this, and we are gonna pipe it to more so that we can see step by step, page by page what it's finding. So we're gonna try to find clues about what it's doing. So we cannot see anything here. It looks like something obfuscated. You know, it's not human readable. It's nothing that makes sense. I'm just pressing space bar in the keyboard, and it's gonna try to give us page by page what it is finding. We don't see anything useful, as you can see, which might be the case because normally the malware is gonna try to obfuscate until running in memory. So here we have simple stuff, nothing new. This is just like an language related. You know, this is interesting because those different DLLs we can see there, we already saw those are related to the import table, but it's not related to the malware functionality, so it's not giving us any clue. So we are done. We didn't get anything based on the strings. Okay, so we're ready to go. We're gonna launch this guy. So we double click on it, guys. We're gonna see right away in Process Explorer is popping up right here, and it's gonna telling us all information about this malware, all the DLLs being loaded as we know before. If we right click, if it would have been a second process dropped from this process, we're gonna see it right here. This is not the case. We right click on process properties. If we go to, for example, TCP/IP, there is no information there. So it looks like it is not doing any connection, but we saw in the sandbox, right here you go, we can see right away it is connecting to this specific IP. It's gonna doing a send, which is starting to communicate with the server. But it is interesting that we are not seeing any communication, guys. Okay, so let's make sure that we have internet connection. So we click ping on Yahoo. We can see that we have internet connection. So then it's not our case that we can see that for some reason it just is trying to send a send, which in TCP is the first step to first synchronize TCP based with the host, and after the synchronization it's going to start interacting. But we are seeing that it is just a send and there is no response. That is telling us that that specific server is not, for some reason, is not open, and we can see that it eventually just disappeared. Okay, so let's check process. Well, first of all, let's check Wireshark to see what's going on here. Okay, so Wireshark, we can see that it is a lot of information, but we can try to search for our specific IP that we saw there. So we can go here and go to TCP, we click enter, and we can see here all the different IPs being contacted. As you remember, we saw one specific IP which was connected to that to the HTTP. That we can try to find it here. Here it is. Here is the IP, and you can see this IP is 185.19.85.153. That's an IP that it is connecting, which is actually related to the IPs that we saw in the sandbox, if you write it down. So, but with this IP, guys, you can see that there is a SYN request, and after that, there is nothing. We are expecting a three-way handshake here, which basically is a sync, an acknowledge, and then a second acknowledge to start information, to start communicating. So we confirm here that it is just a SYN request, but nothing else. And let me show you how a normal sequence looks like so that you can understand it better. So here we have, for example, this our source IP connecting to this destination, and it is also sending the SYN request, right? Right away, that specific server sent a sync acknowledge, which is saying, I received your sync request and acknowledge that. And the third step and final one in the synchronization phase is the server which initiates the connection sends to that destination the acknowledge. That's the three-way handshake that it is needed. And after that, we can see that they start communicating. You see that? In our case, we only saw the sync request and nothing else, which is telling us that the server is not responding for some reason. Okay? And finally, let's go to the process monitor. Here the process monitor is telling us all information about this file. We can filter it out with those options here. What I'm gonna do is I'm gonna just say, hey, you know what? Only show me the registry. I don't wanna know anything about the other details. Just show me the registry. Here we can see that all the information about the registry, what the malware is doing. Here we can confirm if we go down at activities that we saw in the sandbox before. For example, we can go down, and eventually we can see here the operation being implemented, like open, which is kind of opening those different registry keys. Eventually, guys, if you keep going down, we're going to start seeing how it's going to be querying software related. Let's go there. Here is just the WinSock, and here, let me check. Here you go. We can see Qt8 software, so we can see that it is trying to find FTP software as we saw before in the sandbox. So we can also grab that information here. FileZilla, Turbo FTP is trying to find those different software, which is what we saw before, guys. So this is just trying to confirm that we saw before, so that you can see that it is trying to find software that we relate to FTP client. Okay, so but we can also say, hey, don't show me anything about registry, show me something about the file system, what you are doing inside. Okay, so we can see that this is the place that we run our software. We can see here if it is trying to write or you know, do other activities in the file system, those different DLLs that has System32. So then we can see here, for example, all those different options in the file system related. We can see if something was created, if something was open, and something interesting is, so that you guys know, is that the System32 folder is a well-known. But how do we know what it's doing? So in the right side, you can see the desired access. For example, create file on that specific malware folder is trying to execute, which means open. But if we see the DLL is trying to read it, here is what that is telling you. If here you find like writing, that's different, because it's trying to override a system DLL. But you can see here that all of them are read. So basically it's just reading those DLL, which is telling you that it is a normal process. Okay, you can always go and, for example, click on find, and you can search for specific DLLs like write file. We can see that it is not write file, it is not writing anything in the file system or any other, like let's say delete file. So we don't find anything of those. It's a quick search on our system. But obviously, if you keep digging down, let me open up a little bit this guy, you're gonna find everything related to what it is doing in the host. Okay, guys, you can start seeing here that again it is also trying to find software, FTP software like Nova FTP and FTP info, and you know, all the different FTP clients that we saw before in our sandbox analysis. Okay, so let me just go a little bit up so you can see other clients that is trying to query. Let's see, we see other guys here. It's too much information. That's another thing, guys. It's too much information that sometimes is not very good, but it's time consuming, but it is always valuable. Well, anyways, I show you those different software, and feel free to dig into this. Like, for example, we can search for, let's say, find FTP. okay, it's gonna find FTP related actions. Like here at the bottom we have FTP info. So you wanna kinda confirm or search for more information, you know. He was Nova. Let's try to find again another FTP guy. There is no more FTPs here. Let's try to go up. Anyways, you can find all of those guys here. You can keep going up if you want. You know, here you have the 3D FTP, which is another software of FTP. You can keep going up. You know, now we have Blaze FTP. And anyways, guys, that's the idea. And also we can deactivate this. Actually, that's the recommendation, to try to activate just one single view so that you don't be overwhelmed with information. If we go to TCP, we can also confirm here that we just described before that it is trying to connect to that specific server. That specific server is actually the server that we saw in the sandbox, and it's doing HTTP connection. So it's kind of something that we just confirmed before. Okay, so that's pretty much here. So, but since we saw that it is not connecting to internet, right? So we need to try to find what is the callback. So since it is not connecting to internet, it is not trying to send HTTP request because there is no response. So here is another strategy, guys. Instead of using Wireshark now, which was really useful, we can say stop and quit, or we can stop and save if you want to save the pickup. We don't want to save it now. So what we are going to do here, guys, is we're going to run another tool that we have, which is called FakeNet. As you remember it, it's going to fake internet connection. What we want to do here is going to it must be run with privileges. So let's run it again. Right click, run as administrator. And this, guys, for example, is going to fake, in this case, SUS, into thinking that it is actually connecting to the HTTP server. And probably we're going to get the callback, the HTTP traffic that we saw in the sandbox. Okay, so let's try to rerun it again. We're gonna run it, and you can see right away that we got the callback. We got that specific traffic that we were seeing in the sandbox. And the reason we are seeing is because, as you can see here in the DNS, when it was trying, the SUS was trying to request to that domain, FakeNet says, oh yeah, here is the domain which is in the local host, and then it started catching all the traffic. That's the magic about FakeNet. Okay, guys? So here we have the traffic now. We are confirming that it is going to that specific address. And more than that, if we close FakeNet and we go to the software where is FakeNet, we can see that there is pickups already captured for us. We go to view, let's say the view details pane, and we click on the date modified. This is the latest pickup created for us. If we double click on it and we click on DNS, we can see right away that one of the queries was trying to resolve the malicious domain panel3d.oxfrontal.com, which confirms what we saw. And see this, the destination IP is our local host. That's the reason we were able to intercept it via FakeNet. If we click here on HTTP, so that we can see only HTTP related activity, we can see now that we have information, not as before. If we right click and click on follow TCP stream, we can see that we have the post request, but this is something that is more information than that we saw in the sandbox. We can see the post request, but the content being sent. This content, guys, looks like obfuscated, so the only way for us to know what it is doing is by doing an in-depth analysis where the reversing engineering efforts come into play. But in our dynamic effort, this is kind of the limitations where we cannot get that details. But it is very important for us to get them in order to know what it is being exfiltrated. And here we have the post request, and this is also helpful for us to add detection via snort, as we're gonna see in our Defender Techniques course. Okay guys, this is FakeNet. That's pretty cool. That is helping us to understand what is going on. And now let's check another thing. If you remember, we checked the strings of that specific program, SUS. We didn't get anything, if you remember. So, but let's try to do another really good dynamic task, which is dumping the process from memory. And let's see if by dumping the process from memory, we can get more information. Okay, so we're gonna come here to our documents, exercises, and malware. So here we're gonna run again SUS. Since we are in our virtual machine, we can do this anytime we want. And by the way, sometimes the malware won't run if it runs already, or sometimes in this case, as you saw, it will run and then it will stop running. But in some case, and that's good because we can run multiple times. But in other scenarios, it will run all the time, so you cannot run it 2 times. You need to reboot, so you need to revert your virtual machine in order to go to the clean state and reinfect it again. In this case, we are fine. So we're gonna double click on it. Okay, we can see it popping up right away in Process Explorer. Did you see, guys, that it opens a second file? Let me kill it. Check this out, guys. Double click. Check this. Oh, now it didn't catch it. Anyways, but we saw before that it was creating a second source. That can be the reason of doing its own process injection by calling itself and then deobfuscating malicious code in memory and then replacing that malicious code with in memory so that it can run properly. So okay, so let's run it again. We have here SUS. It is running. Okay, and now let's go and use LordPE. With LordPE, we can go and try to find that specific process. We can see it here, and then we just go select it, right click, and say dump full. Okay, so we just go to wherever we want to save it. Let's save it in our documents folder. We need to do it kind of fast because otherwise it might stop working and then we are not gonna be able to dump it. So finally we get here. It is so slow. You can see this guy, malware detected. Finally Windows realized that this is malware, but it was realized after we dump it in memory. That means that probably it was really good obfuscated on disk, and just by doing the dumping, probably it was offering details, and that was the reason it was detected. And actually, it is a good practice, guys, to disable all the different security products in your lab, so that it doesn't interfere like in this case. But in this case was obviously put in place so that you can, guys, see that by dumping the malware, probably it can give you more clue about what it's doing, and that was exactly what happened here. So let's see how we can remove Windows Defender. So if we go here and we click on Defender, we double click on it. Okay, we go to settings, we click on disable this guy, and right away the computer says, hey, you are on risk. It doesn't matter, we know that. Okay, so now let's try to run it again. We double click on it, we can see that right away. You see, guys, the two processes. That means it is doing process injection. If you want to know exactly what it's doing or what it is being injected, that's another approach. That's called reverse engineering, where we can go those details. So check it out, that specific course. Okay, so it's running. So we go to LordPE. We also again try to find the process running here. We found it here. We double click on it. Here we right click, dump full. We're gonna dump it there. We click save, dump done, and in this case the Windows Defender is not interfering with us. Now let's run a strings again on that specific guy. Strings dump, which was the one that we saved, and then we pipe it with more. Let's see what if we found something different. You can see that LordPE, it adds in the header its own signature so that it knows it was done by that software. We keep going down. As you remember, initially we didn't see anything, right? Nothing available. So let's see what we got here. See this, guys. A list of passwords, a dictionary, which is probably used by the malware in order to find passwords in all the different FTP clients that it was trying to search for. This is juicy information, guys. So it's giving us more details about the malware. Okay, here we can see also, guys, the panel3d oxfrontal.com URL. In other words, if for some reason you don't even are able to run it or is not connecting to internet, by dumping the malware from memory, we can see juicy information. Okay, so we can see also here the headers. This is useful because we can see that the headers are hard-coded. You can see the user agent is hard-coded. Normally, when you are trying to detect traffic, you need to skip the user agent because it is normally generated by Internet Explorer. But if it is hard-coded, it is a strong indicator that that specific user agent is custom, and therefore we can definitely add it for detection. Here you can see cute FTP on all the different FTPs that we already saw in our process monitor activities. And I mean, juicy information, guys. Feel free to go through it. And you can see SQLite, which is a database. Let's see if we get something else. But basically we got, see this Microsoft IE FTP passwords. You know, it is confirming, but more in detail what we saw. It is able to connect, you see, with FTP, HTTP, HTTPS. Okay, so you can keep digging. See this, guys, POP3 password. That's telling us that it's not only FTP. It is probably also able to steal POP3, which is email related information. SMTP also, NTP, sorry, NTP. So IMAP. So this guy is also able to connect to internet with IMAP POP. So, but if we want to know exactly what it is doing, we need to do reversing. But it is kind of giving us the clue that probably with the passwords found, it will try to connect to the POP3. In other words, into the email server of the victim machine in order to grab the emails, or it's gonna try to send to its own server all the details. Okay, we can keep pressing the spacebar to see more details, but basically that's the idea, guys. So we got all the details by dumping the malware from internet, which is definitely something useful for us. Finally, last but not least, let's run auto runs. Auto runs is gonna tell us if the malware by any chance was set up to be run after a reboot. We can go to logon, for example. We see wherever it's been executed after run, like in the run key. You know, we can see that it's gonna run those guys, but we don't see anything about SUS, right? We can go to Explorer, Internet Explorer. If it is writing a helper object, which is also known that it can create a DLL, so that every time you run Internet Explorer, it will be loaded. The schedule task, if it is being added as a scheduled task, we don't see anything. As a service also, if it creates a service in the system in order to run, which is very common. If it is a driver, guys, installed by this guy, normally this can be obfuscated, but normally this can be also useful. Boot execute, image hijacks, you know, all the different techniques used by the malware in order to run after the reboot is gonna be found here. Okay, so far the malware is not installing anything at first look. So, but this is a really good tool for us to know if something was added into the system. Okay guys, that's pretty much it. So hope you enjoy it.